All right, 6.2 parallelograms, sides and angles of a parallelogram. Don't forget, parallelogram is a quadrilateral with both pairs of opposite sides are parallel. So make sure that you understand that right now when we start classifying quadrilaterals, this one is a very general definition. All it's telling you is that if you have a quadrilateral, four sides, and all you know is that the opposite sides are parallel, both of them though, then we know it's a quadrilateral. We're going to go through these theorems right here, 6.3 through 6.6, and they're very basic. They just simply indicate, for example, first talking about sides, basically says opposite sides are congruent. So let's go ahead and just annotate that. Opposite sides are going to be congruent, and then you can see that on the picture. If these two little markers, two little bars indicate that they're the same, and you can also see over here one marker and one marker over here. So that's the first basic one. So let's look at the example in the back page, and then we'll jump back to the notes. On this first example in the back, make sure that you look for this. They have to indicate that it's a parallelogram, or you have to somehow find out if it's a parallelogram. So as soon as I know if it's a parallelogram, either they indicate it or they might put little arrows on these right here. So if I know this is a parallelogram, I know these are parallel, uh, but that's it. It doesn't really help me know that those two are parallel, but I'm going to use them right now when I look at angles. Right now, the only thing that I know is that they're focusing on sides. They're giving me this side and then this side. You have to make sure that you remember, since it's a parallelogram, I know that opposite sides are congruent. Just like the theorem just said. So even though it didn't indicate, I know that this one is the same thing as that one. So my equation for this problem is going to be basically 4x minus 1 is equal to 23. So this one's a very simple problem. All you have to do is remember this theorem that in parallelograms, the opposite sides are congruent. I know this side is going to be congruent to this side because it's a parallelogram. So just set them equal and then just solve for x. So plus 1 plus 1. I have 4x is equal to 24. Divide by 4, divide by 4. I get x is equal to 6. Now just be careful on the directions because sometimes they may indicate, solve for something else. But in this case, they just wanted x. Okay, that's dealing with the sides. That was the first theorem right here. Okay. Now, if we go back to the notes, well, before we do that, if we look at example 2, notice how this time it's still a parallelogram. So I know that these two sides are parallel, as are these. By the way, these arrows just indicate that I'm basically indicating that these two lines are parallel and these two lines are parallel. Now this time I'm dealing with angles, not sides. So if I go back up or to the theorems, now I start looking at the angles and there are theorems, and really these we don't have to memorize them because I'll explain how to basically prove them. If you look at this one now, it says opposite angles are congruent and consecutive angles are supplementary. And that's basically this picture right here. If you notice how the opposite angles here, this one and the one across it, those angles right there are opposite and they're congruent. The same thing for the other two. Okay. The one that we're going to prove right now is why is it that consecutive angles are supplementary? It has to do with the parallel. So let's go back to example 2 and let's try to figure out why are consecutive angles. Oops, did not want to do that here. So why are they supplementary, or why do they add up to 180? Alright, well let me just draw this. Anytime you see parallel lines, let's just extend them. Same thing for these. And we've done these problems before, where if you have two parallel lines, if I were to take this angle right here and this angle over here, I know that those are corresponding angles. So right here, these are corresponding. And if you remember corresponding angles, they are congruent. So if I want to move this angle 6x plus 5, I can put that over here, 6x plus 5. You can also move the 103, by the way, and move it to the other corresponding location. But right here, now that you've moved these, now I kind of look at this line right here. And when I look at these two angles right here, they form a straight line. And a straight line I know is 180 degrees. So from here, I know that 6x plus 5, if I add the 103, it should give me 180 degrees. And then just solve this equation. So I have 6x, if I combine like terms, plus 108 is equal to 180 minus 108, just the algebra here. 6x, this goes to 0, is equal to, what is this, 72? Divide by 6, divide by 6, x is equal to 12. Okay. And this one they were looking for x. Alright, so that was consecutive. Consecutive were right next to each other, which if I just use my properties of parallel lines cut by a transversal, I can figure out this theorem without actually having to memorize those theorems. Alright, let's look at the next example where they want us to find x, but this time it's still dealing with angles, so I would do the same thing. If you see a parallelogram and you're dealing with angles, you may want to extend, draw lines this way, extend those parallel lines, and then just use the properties that we did when we were looking at these right here. Now this one, it does require us to move some angles a little bit. For example, I'm going to start with that 26x plus 6. I'm going to go ahead and remember this line is parallel to this one. I can only jump from one parallel line to the next one. I'm going to go over here to W, and it corresponds with this location over here. So I'm going to put 26x plus 6. And then the same thing. Now I'm going to go ahead and shift over from here. I'm going to move up to V, and it's going to show up over here, 26x plus 6. And now these two angles are across each other. What do I call that? Vertical angles. And I know vertical angles are congruent. So I can set these equal to each other. So my equation here is going to be 26x plus 6 is equivalent to 27x plus 2 because of the fact that vertical angles are congruent. And then the same thing, just solve for x. Use your algebra skills. Minus 6 minus 6. If you wanted to move the 27 or start with the 27, you could have done that also. 2 minus 6 is minus negative 4. minus 27, minus 27. How you solve it is up to you, just so long as you get the correct answer. Just be careful with your computations there. When you divide by -1, negative divided by negative is a positive. Now just be careful here. We found x, but this time they wanted us to find the measurement of angle x. And angle x is this one over here, or I guess this one because they're vertical angles. So I know that measure of angle x is equal to 26x plus 6, and then just substitute x equals to 4 that we found into this. So 26 times 4 plus 6, and what is this? 112? 110. Okay. So just be careful when you're solving for x.